Hey everyone, welcome back to our YouTube channel, where smart ideas meet simple execution. In today's video, we're going to build a DIY Lipo battery charger that can easily charge 2, 3, or even 4 Lipo batteries using just a single mobile charger. So without any delay, let's jump right into this exciting and practical build. To begin this project, we first selected high-quality wire connectors, as reliable connectors are essential for stable and safe electrical connections. Next, we used a blank PCB, which can be easily purchased from any electronics store or professional PCB manufacturer. A blank PCB allows better circuit organization and gives the final build a clean and professional appearance. Assembly and alignment. After that, all wire connectors were carefully placed and aligned on the PCB. Once the placement was complete, we moved on to the soldering process. The soldering here is simple, but maintaining clean solder joints and proper heat control is crucial, just as you can see in the demonstration. Good soldering not only strengthens the circuit but also reduces electrical loss and improves overall reliability. The final result is a clean, durable, and professional-grade PCB assembly. After preparing the PCB, we selected the required wires and securely attached them to the board. Each wire was placed carefully to ensure proper routing and a neat layout. Next, we connected all the wires step by step. I am using proper soldering for every connection. The wiring process is very simple. Once all the wire connections were completed, we moved on to the charging section. For this build, we are using 3 charging modules. All 3 modules were fixed firmly in place using instant glue to prevent any movement during operation. After fixing the modules, we completed all the electrical connections for the charging circuit. Make sure to follow the same connection pattern while assembling your circuit. For your convenience, the complete wiring diagram will also be available in the description. Now, step by step, we complete all the remaining connections. While making these connections, it is very important to ensure that no wire is misplaced or loosely routed, because even a small wiring error can cause the circuit to malfunction. Clean soldering also helps maintain stable electrical performance throughout the circuit. After completing the wiring, we move on to the jack connections. First, we finish the main jack wiring carefully, ensuring correct polarity and firm solder joints. We have completed all the connections. Next, we connect the 5-volt input jack and complete its wiring following the same method. With this, all required connections are successfully completed. To properly house all the components of this project, we used a plastic pipe body as the enclosure. This type of body is lightweight, durable, and easy to customize for DIY, as well as semi-professional builds. First, we carefully marked the positions on the body based on where each component needed to be placed. Accurate marking is important because it ensures proper alignment and a clean final appearance. After marking, all required sections were precisely cut. Using instant glue, we securely fixed the lower internal parts of the enclosure. Once the base was ready, we installed each component into the pre-cut openings, ensuring a tight and stable fit. Friends, carefully fit all components inside the enclosure. Ensure no wire is loose or out of place, as even a small misalignment can stop the project from working. To give the project a more advanced and professional look, the enclosure was finished with paint. This not only improves the appearance but also adds an extra layer of protection to the body. After that, all components were neatly arranged and fitted inside the enclosure, and finally, the upper part of the body was assembled to complete the structure. If you want to take this project to the next level, you can also design a custom 3D printed enclosure for an even more premium finish. With everything assembled, the project is now fully enclosed and ready for final testing. For testing, we first connected the charger to the Lipo battery charger. As soon as we switched it on, you can see the indicator light turning on, confirming that the project is functioning correctly. To perform a practical test, we used a Lipo battery and connected it to the system. Immediately, the green light started blinking, which means the project is fully operational and working as intended. The best part is, when your battery is fully charged, the green indicator will remain steady. You can try this with multiple batteries to verify. During charging, the red light will turn on, showing that the battery is in the charging process. This simple visual feedback ensures that the system is reliable, safe, and easy to use. That's all for today's demonstration. Stay tuned for the next video for more exciting updates.